Hello, everyone, and welcome back to yet another episode of Expert Insights Live. We've got Serge with us today, and before we start, if all of you can hear us, if you can just drop in a message, that would be great, and we can then get started with the session. You can see one comment, which is probably coming from earlier. Hi, David. I hope you've joined us live. Serge, while we're waiting for people to comment in, there might be a bit
Sure.
of a lag. Why not just begin with introducing who you are?
All right. So yeah, I have a long career spanning a couple decades, but I became a data scientist officially like 5 years ago, something like that. Um, and but I was already working with machine learning a few years before that, and with Python, you know, 5 years before that, and data in general for like as long as I've been a professional. But in data science, I work in agriculture. So, I deal with, predictions to help farmers farm more sustainably. Um, well, I've been passionate about interpretable machine learning for a while now. I mean, when I came to a realization, I think it was back in 2017 or 18, that, like there was no way of debugging a model. Like
Mhm.
often that was the roadblock. Like as someone that was, a software engineer by training, like getting to a point where you're like, okay, I don't know why this happened, but this black box did this, is really frustrating. So I figured, and this all happened when I was in my startup. I just hadn't come
Mhm.
up with a term for it. So I had a startup, if I rewind a bit, somewhere in between becoming, uh, stop being a web developer and software engineer, start being a data scientist. I had a startup for a couple of years, and it had quite a bit of machine learning. But I was very naive. This was 2015, 16, and so on, and I didn't really, I was working with this technology, but I didn't know like a lot of things about it. So um, I just was hitting those roadblocks and didn't understand why, and I didn't have a term for it. And then it wasn't still I started studying data science that I'm like, okay, I'm starting to see this term, but honestly, there was only discussion about it in academic circles and very little in
Mm.
practitioner circles, and that was concerning to me because all these people are adopting machine learning and they have no idea how to debug it.
Yeah.
Um, so that's kind of what got me down this path till you know 2020 start writing the first edition.
Perfect. Thanks a lot, Serge. And I can see a lot of people have joined in as well now. Thanks for confirming, Tarek, that you can hear us. Welcome to the show. We've got Juan who's joined us as well. If all of you can tell us where you've joined us from, that would be helpful, just to get a bit of context. Ricardo has joined us from Orlando, Florida. Welcome to the show, Ricardo. And as all of you can see, there's a ticker going on at the bottom.
Mhm.
We have a couple of giveaways during the live session. We'll do one somewhere around the between middle of the show and one towards the end. So if you can just comment hashtag Packt, that would be great. Thanks, Tejas. Tejas has joined us from Mumbai, India, and he says AI in agriculture is must in my country. I'm from India as well, so yeah, I agree to that. It it can done a ton of good. So if you have any queries, please feel free to add into the comment section, and I'll pop it up over here, and Search can answer it for you. So while you all don't have any queries, let me begin by asking a few queries that I have, Search. You mentioned an important term over here, black box models. So let's start with the basics. What are black box models?
Okay. They're just models that are more complicated. Uh, like if you think of a model like a machine that takes
Mhm.
in an input and pops out an output. A black box model is one that is so intricate that you can't quite understand what's going on, and it's really hard for you to come up with something like an equation or something like that that you can easily like understand. Like the way it's usually explained is like you can pretty much just by looking at it understand, okay, this is what happened, right? And so the bar is pretty low for something to
Mhm.
become black box, because when you think about it, like it's not even referred to it that way, but even models that we think of as white box, like linear regression or decision trees, can just if they have more than a handful of features, or in the case of a decision tree, grows beyond a certain amount of levels, if the tree becomes like really deep, like all of a sudden it's no longer interpretable.
Yeah.
So is it really white box? Like, so I think that the line is really hard to establish. I mean,
Mhm.
I usually it's seen as model classes. It's seen like, okay, well, neural networks definitely black box, you know, and a number, certain ones are always seen as white box, but it's really more about complexity than anything else. Another factor that goes in is what happens in the machine.
Right.
And that, of course, makes it more complicated because it can be complex just because of the way it was trained, and what is the machine of that that was created. But another thing is um, what happens inside, which definitely makes it less interpretable. Like
Mm.
linear regression is linear by definition, right?
Right.
And linear means it can be easily divisible, so which one each of the parts uh, add to like to the outcome. So if you see it as a machine, you say, well, each feature is going like in a different chamber, and then at the end of the process, it's adding up. And so you can really much divide which one of these features contributed to the outcome. So it's very easy to do that, and it keeps things simple. But with other models, it's not like that at all. It gets messy really quick.
Mm.
So linear is one of those properties that helps keep things simple and interpretable. And that's one of the reasons why black box models are complicated, because
Right.
more often than not, they're not linear. And there are other properties that the book discusses, like monotonicity. Perhaps to me is even more important than being linear is being
Mm.
monotonic, because monotonic, I mean, something can be linear or not, but if it's not monotonic, then it's just going to be a lot messier, because it just means that as the feature uh, increases in value, the outcome will not increase in value. It might go up and down. It's not necessarily tied in that way. So something being nonlinear, can be more forgivable in terms of
Mm.
complexity than something being non-monotonic.
Right.
Um, and then, of course, the interactions is another thing. How the features interact um, is going to tie into that as well, into that complexity, and how many interact at once, and that sort of thing. Because features do depend on each other. Like if you think of it intuitively, they're features that in our world always kind of act in tandem, are related to each other. So when you discuss one, you need to talk about another. Like in the book, in the second chapter, we talk about how like there's different measurements of, like for instance, heart rate, like usually comes in pairs. Like they
Mm.
usually tell you, well, your high and your low is this, and like you don't discuss it as a single number. So
Yeah.
those are two features that interact. Usually when you see data about them, you're not going to see one or another. And the outcomes have to do with both.
Yeah.
Um,
And especially when you work with a high volume of data, the bigger the data, the more important it gets to be able to explain it.
yeah.
In fact, you touched upon a good point about the next question as well. Tejas on YouTube inquires, can we ask questions? What does this book is offering us? So tell us more about your book, the latest edition of Interpretable Machine Learning with Python.
Okay, well, the kind of questions, I mean, questions is a good way to phrase it, because to me, like the most important question in data science is why. I mean, people get caught up on the how, and the
Yeah.
how is something, well, I used to say 4 years ago was, or 3 years ago, 2 years ago, when the first edition came out, oh, you can easily find out about the how in Stack Overflow and in Google. These days, you can ask ChatGPT how to do the how. It's irrelevant. But the why is still really complicated. And it's not something easily that ChatGPT can come up with. It takes a human still to interpret outcomes of models in a relatively reliable and consistently reliable way. So I think we need to be asking those questions, and the questions that the books helps us kind of look into have to do with why the model is doing what it's doing. You know, so it's like, why does it have these outcomes? You know, like, is it because of these features? Is it, do these features interact? Does this feature, is this feature tied monotonically with the outcome in this way or this other way? You know, is you know, what made a particular decision happen? You know, um, and is it fair that it did that? Which can be a more complicated thing to determine. Or is the model holistically fair? Is it, can be seen as a fair, you know, the way it's making these decisions. And then also, can we trick the model? That's another important one. And can we ensure its robustness against this kind of trickery, which is called adversarial robustness? And yeah, there's so many questions that are derived from these things that, you know, can be kind of distilled on a case by case basis. But it's pretty much has to do with, you know, where, you know, from what angle you're seeing things. You know, because if you see things in terms of, okay, this is like a case, and you're looking at the evidence of something, like there's so many ways to split the data in such a way you might find different outcomes. And so there's Akira Kurosawa had a movie, Rashomon, I think it's called. And so there's an effect that comes from that, you know, like it's the typical like murder mystery effect. You have to, you know, like, you have to question all like the people that came to the party to figure out, you know, how did this murder happen and who was to blame. So like that's it asking the right questions is not just, okay, there's one single question, is about trying to covering all the different angles to come up with a conclusion that is sound. And to be fair, like even the a single chapter can't go to the level of detail as detailed as it goes to go down that rabbit hole, but hopefully inspires people to do that with their projects, because it, you know, like most of us practitioners work in industry, or we work in you know, academic institutions, or like in government, you know, whatever I do, you know, they're paying us because like they're they're stakeholders that really rely on good models. So we can't just, oh, say okay, we got this level of accuracy and call it a day, because these models, even if we caught, like we got like a 97.9% accuracy, there's still 1% that is accounted for.
Yeah.
And I'm not saying we have to chase that 2.1%, be greedy and try to get it. We might never do that, but maybe we are, that 2.1% is not the most important 2.1%. Maybe the actually the model is right for the wrong reasons some of the time, and we don't know that, so we can fix that. And maybe also it can happen that like the model's acting unfairly. So the 2.1% that were actually failing is one we should probably look into. So, and we could adjust that fairness so it's more balanced. So there are many things that we can see from once we dig into the error.
There's another question from Tariq on LinkedIn. Any thoughts on interpretability of LLMs?
Oh, yeah. The book looks into it has a chapter on NLP. I mean, it doesn't go. I mean, I'm not making the assumption that everybody has a GPU, even one with, I don't know, 16 gigabytes of RAM at least, because that's what you would need to maybe load, like, and not even the stronger ones. I'm talking like one of the open source llama ones to actually interpret it, and it still would be kind of painfully slow. So what we do in that chapter is the BERT model, which is a large language model. A lot of people have forgotten about it, but it's actually a great model for a lot of different things, and one of those applications, sentiment analysis. I'm not doing a binary sentiment analysis in that chapter, going a little further and doing one with a range of emotions,
Mm,
because I think there's a lot of use cases where that would be useful. Binary is reducing it a little bit too much. It might be good for, like, if you want to gauge more or less the sentiment of customers or audience of an event or something like that, through their comments, and just have some idea. But you're trying to do something more complicated, like many companies do, and try to understand what is driving sales. Um, it might not boil down to positive and negative. It might boil down to a range of emotions. And so, anyway, going back to that, BERT is the same techniques I'm using with BERT are useful with our all other large language models. So if you happen to have a GPU and all that, you can expand it to other types of transformers beyond simple encoder or decoder. Um,
perfect. We've got quite a few questions from YouTube. So Lazy Data Scientist inquires, can you share interpretation of time series model except regression model?
yeah, you can interpret time series models. Some of them are, I would say, they're white box because they're easily understood by a formula. Um, you know, um, moving averages ones, ARIMA, all those, GARCH. They're all like based on a formula, so you can interpret that uh,
Mm,
with not much trouble, and they're usually very simple formulas. Well, it depends what you define as simple. Sometimes, like, of course, they have exponents and things like that, but um, yeah, they can be dissected into their individual parts in many cases, and seen that way. What the chapter in the book looks into other kinds of models that are more complicated, especially when you're dealing with multiple input variables. When you're looking into, okay, well, you're and the chapter involving time series looks into traffic, and traffic is actually a very complicated problem. I mean, I've met people dealing with this kind of problem in, I think, Lyft, but Uber has similar, and they run um, tens of thousands of different models on a nightly basis. They're training them all the time, because what factors into their traffic estimates uh, is can vary from location to location, and it can vary depending on the time of year. If there happens to be a big concert in a place, they have to factor that in. Maybe they did not know that till last minute. So there's a lot of things that go into that. So we're not talking about auto-regressive models here anymore. We're talking about more than that. And I said auto-regressive, which is the case where, like, for instance, you have, you know, yesterday's traffic has, you know, is impacts today's traffic, and okay, or maybe the last hour of traffic impacts this hours of traffic, and you know, an hour from now's traffic. Like, that's not this kind of model. We're talking about the kind of model that's impacted by, you know, other things like weather conditions and so on. And I deal with a lot of that, you know, at my work, because you know, obviously plants um, have to do with weather, and weather changes all the time. So, uh, like, what I like to look at, and it's just an exercise in, it's not so much, I usually don't, to be honest, usually take it out of a framework that is time series and make it into a simpler model. Uh, but the time series exercise is great because you can train a time series model, a very complex one, and try to understand what it looks at. And that's how you start to realize, oh, like, you know, these plants, say soybean in this area is not, is the growth of it is not impacted by, you know, the last 20 days of weather. It's, in particular, it's mostly impacted by, I don't know, like the humidity in the soil for the week prior to it being planted. And in particular, not the day before, but the 3 days before that. You know, like, and you can look at these things by actually training a complex time series model. And once you look at that, you can actually turn it into a tabular problem, or just extracting the features you need and training a much simpler model with it. So it is a very useful exercise to do interpretation in time series, you will find.
Perfect. We've got Swellen who joined us from St. Lucia. Welcome, Swellen. And they have a nice question. Are there practical examples to practice from? Um, I have the GitHub repository of the book open. Should I just show it to them?
Yeah, for sure.
I could just flash it up, and if you want, you can just walk through it. Let me know when you can see my screen. Can you see it?
Hmm.
There you go, Swellen. If this is the GitHub repository of the book, and these are all the examples and all the code is over here. What the book is about, what are the things that you need. And when you scroll down, there is a detailed list of all the exercises. Serge, I'll let you walk through it.
Yeah,
About the
like
example.
each chapter from 1 to 13. The only
Mhm.
chapter is not, that doesn't have a hands-on example is 14, but all of them have hands-on examples. Um, so and they're all in Jupyter notebooks. Makes it very easy for data scientists and machine learning engineers of all levels to tackle them.
Yeah, and it's linked on Google Colab, so you don't have to do anything. You can just click on the link, and you can see the entire notebook and the example over there directly. So it's as simple as that. So yeah. And coming back to the question from Lazy Data Scientist on YouTube, PCA interpretation, do you cover that in the book? Search?
No, no, I don't. Unfortunately, like, there's only so many things that I could cover. And I think in the first edition, I did a little bit more into those kind of topics. But then I realized, as data driven as I am, I looked into, I think Packt shared with me, like, the statistics of what parts of the books were being kind of read the most. And so one of the, I wanted to add a new chapter for natural language processing, that I was noticing was becoming an increasingly more important topic. The first edition only had like a half of a chapter devoted to natural language processing. So um, yeah, one of the I took several decisions like that, like cutting out little parts that dealt with things like that, things like dimensionality reduction and so
Yeah.
no, it's not covered, and I think it is in all fairness, it's covered quite extensively in a lot of different area, in all kinds of articles and other books that don't relate to machine learning interpretation because it's it's not really it's a technique that's leveraged by a lot of machine learning practitioners in preparation and in models as well,
Mm.
but it's not. It's in its own right. It's not a model. So I think.
Yeah. And
I
I'll
mean, it's
basically,
at least the supervised version, supervised learning, which is something this book focuses on, supervised learning models.
yeah.
Um,
And as they say, if you can't say anything different about it, it's best not to say anything.
yeah,
So it's better than being repetitive in the book from
yeah,
what's already freely available.
yeah.
So thanks for that, Suraj.
No problem.
So I'll wait for a few more queries to come in, and while they are coming in, I have a few queries for you as well. So, Suraj, we discussed a lot about interpretability and different features of it, like models can be explainable, fair, robust. But why is it really important for them to be explainable, fair, and robust?
Okay, you typically um, it's discussed from an ethical standpoint, and
Mm,
you could definitely go down that route and say, well, you could produce harm, and harm is bad. Uh, I mean, for any of those reasons, like we can see it in any form of technology. If we don't make sure it's robust, it's going to fall
yeah,
apart, and it
yeah,
might cause some harm. And that's going to vary from use case to use case because like we don't know. It's very different to be discussing about a machine learning model in the case of a self-driving car as in the case of a medical system or a social media site or an e-commerce site.
mm,
It's going to vary, but there you could see things. As soon as people rely on them, if they become unreliable, that could be harmful too. And then as far as like the fairness goes, the fairness, same kind of situation. It's also going to vary. Some are more subtle. If you're unfair to people in social media, they might
mm,
never notice, but the outcome might impact them in some way or another. And and so, but if it's something that's making decisions for people, like maybe changing their credit score or something like that. I mean, that can easily become harmful. So yeah, as I said, there's the ethics of it, but there's also the business side to it. And of
yeah,
course, it for a number of reasons, it makes sense from the business side to make things fair and robust and explainable. And explainable is relates to what I said earlier. Like to improve things, you have to understand them. And to understand them, you have to be able to debug them. You have to be able to go deep into why they're doing what they're doing. And if you can't do that with your systems, then you're going to have all kinds of issues.
mm,
And they might not be apparent at first sight because, as with every complex system, like like you might not even know that you have a problem till you have a problem.
yeah,
So it pays off to be curious from the get-go. It pays off to test things for reliability and usually it's I'm not to say that right now in for quality assurance in machine learning people aren't going to they're not doing accuracy testing and load testing for speed and things like that, but they might be testing a bunch of fringe cases, things that they don't expect to happen. They
mm,
might not be testing for fairness, for robustness. for the things that happen in the book. They might not be explaining outcomes for their customers, or simply to understand when a customer calls and says, hey, like this happened, why? It'd be nice if the customer service agent was able to pull up their file and then click on the outcome and then say, okay, explain. And then it shows them the outcome, why the customer got the outcome that they did.
Right.
But like a lot of businesses don't have that kind of thing in place, and it's not as hard to implement,
Yeah.
as you would think. So that would be good for the business for reputation reasons, for reliability reasons, for a number of reasons. And I can say the same thing about fairness. Could being having instances where they cause harm for unfairness or for lack of robustness could lead to them, um, people losing faith in their business, them losing license to operate, and things like that.
Mm.
We all saw how recently, self-driving car company in San Francisco had an accident, and they had to shut down their operations. They say it's kind of temporarily, but it's the sort of thing maybe they won't recover from. Um, and that's why it pays off to kind of anticipate these things. And I'm not saying that they didn't, but it takes a lot of work to make something ready, for production. It's not just all about metrics.
Mm.
Unfortunately, there's interpretation involved.
Perfect. Thanks a lot, Serge. I'll let you have a sip of water. And there is a question over here by Gauthier Buffy on YouTube. How can I get the book? Great question, Gauthier. I hope I'm pronouncing your name right. There's a ticker going on at the bottom. There are a couple of giveaways in this session. Since you mentioned it, we can bring out our first raffle and we can start with that now. And then we'll do another one at the end of it. So I see that a lot of people haven't entered the raffle. So great for them, but the others who want to win the book, uh, please enter the raffle. Uh, yeah, so I'll just start the raffle and I'll share my screen. So everyone knows that it is fair and I'm not picking out a name randomly or out of bias, speaking of interpretability.
Mhm.
And our first winner is Tariq. Congratulations, Tariq. I can see that you're on LinkedIn, Tariq. So if you can just drop me a message, that would be great. And I'll get you your ebook. Congratulations again, Tariq. We'll do another one. So in case it wasn't you, don't be disheartened. There will be another raffle towards the end. Uh, yes, please comment with hashtag Packt, as I can see a lot of new people have done. So, if you have any queries, please feel free to ask, and Serge will be more than happy to answer them for you. Serge, I'll continue with my queries because I can see no one is asking anything. So, Serge, what are the most common challenges of machine learning interpretability and how to overcome them?
Hmm.
If you can just pick out
Well,
one instance or two, that would be helpful.
yeah. I mean, I think the biggest instance, uh, issue or challenge would be, um, and it's something pretty common. It's how to balance your different, like, priorities. Where should you start on that
Hmm.
journey? And typically, depending on the use case, people start with trying to explaining the outcome, right? And they kind of stop there, and they don't climb the pyramid. And in the book I show kind of a pyramid. Like explanation is like a very important use case, but or like application, but I see it as only the beginning. Like you can go much further than that. Um, you can do error analysis on a deeper level. You can do robustness tests. You can, um, you know, um, look into the fairness issues. So there's a number of things you can do, and depending on the on the use case, you might want to start the other way around on that pyramid. You might want to start with the fairness and work your way down, because that is the most important thing for what you're doing. So it, and then how do you balance things? That's also, it's not just what journey you take into discovery. It's also what, how you're going to prioritize what you find. So
Mm.
that is a challenge, and it's not something the book answers completely, because it's going to vary from use case to use case. I mean, there is one chapter that discusses that, because of course, an accurate model, an inaccurate model will likely be more unfair than an accurate but unfair model. So you have to kind of balance things out. One that is unreliable, one that has that is prone to overfit, is also going to be, even though it's on paper accurate, and it's also going to be um, unfair and unreliable by
Mm.
definition. So you have to kind of figure out the right balance between things. And it almost feels like, okay, well, you're you're trying to assure stakeholders, okay, I'm not making this up as I go. I'm not, I mean, I'm going to set a number or target, and I'm going to work towards that.
Yeah.
But with this kind of problem, you can't do that, because there's an exploration to find what you need, and once you know what you need, you're shooting that, but you're shooting for that, but you kind of have to, once you know what you need to achieve, that's when you draw
Mm.
the line. But it might seem like it's arbitrary, like you kind of drew it out of a hat, but it's the way it needs to be done, as long as you're kind of covering all your bases, so you can achieve something that is balanced. Because in a lot of cases, a single metric is not going to cover it.
It's just normally called chasing the metric. I remember someone coined this phrase on one of our previous episodes, that
Hmm.
people end up chasing the accuracy metric so much that they just keep on working on it over and over and over again. But at times, it is
Yeah,
not really that important.
yeah,
More important than that is understanding it, why it's giving you that metric.
absolutely.
The other thing I wanted to inquire, I have a couple of queries pop up in my head. So before I forget them, firstly, what are the common misconceptions about uh, interpretable machine learning or explainability? If you could answer that. And the other one, I'll make a note of it before I forget.
Misconceptions.
The
Okay.
most common
Well,
misconceptions.
the most common has to do with the name, and
Okay.
it is a very tricky thing. I mean, when I started this journey, there were still a lot of people in the camp that said, okay, well, in interpretability um, relates to black box models.
Hmm.
Um, no, the other way around, white box models, and explainability to black box models. But I'm of the thought process um, that um, black box models are something you actually interpret, because you can't possibly explain it, because you don't understand all of it, and you never will, right? So it's not a very humble thing to say, to be, yeah, but it's more like a semantical thing. I don't know why there is. I mean, it's kind of moved in that direction, because you hear the terms explainable AI, interpretable machine learning, um, interpretability, explainability. Uh, they're often used interchangeably,
Hmm.
but like I think, yeah, they shouldn't, but that's the way they're used. I think they often relate to the same things. They're different properties that we must take in account that are important. Like we definitely, there's the property of being able to understand the model, its inner workings holistically. That property is something, like I can't say, okay, it is the same to have, uh, like a logistic regression model and a neural network. They're completely two different animals. I can say that because one has that property and the other one doesn't. That being said, what terms we use to define that property to me is become kind of irrelevant, except that I happen to have a preference for saying, well, and it's one that was shared by a lot of researchers, when I started this process. And now it seems to be like, okay, explainability relates to, um, what was it, black box models, and interpretability to white box. And I think it should be the other way around for sure, because as I said, we have to be humble and realize that
Mm.
interpreting is interpreting. Interpreting, you can interpret anything. It doesn't mean that you know for sure, 100%. Explaining seems to be a word that conveys much more assurance, and not that level of humility that we should apply when we're discussing black box machine learning models.
Perfect. Thanks a lot. I think Gulrez on YouTube has a question. Gulrez, we've covered this a little while earlier, in fact, just 5 minutes ago, the importance of interpretable but Serge, if you can cover the second part, is it for hyperparameter tuning and increasing accuracy? I guess you answered this as well, just a little while
Yeah,
ago.
yeah. For hyperparameter tuning, yeah, it is a lot easier. I mean, interpreting outcomes beyond beyond just simply their metrics. And what I mean about that is that if we see, like, we have different models and we can see different properties. They might be in the same neighborhood of accuracy, like, but we see one happens to overfit a bit more than another one. And then we plot their, we run something called CHAP on them, and we figure out, well, like, one seems to rely on this feature more than another, and that's the one that
Mm,
overfits. So there we start seeing a pattern and learning a lesson that the feature that's making things unreliable is this one, right? That's the feature. There's something about it, and so from there we can start figuring out ways of making that feature more reliable. Like,
mm,
maybe it's something we don't know at the beginning, but then we realize that that feature, the reason it's unreliable is because there's data quality issues with it. Say it's the age feature, and people lied about their age, right? So the model's not able to make that a very solid connection between age and outcome. And but what if you turned it into an age group? You know, maybe that would make it more reliable, because you know it's going to be less. The maybe in some instances there's a lot of people in a particular age group, but there's less in a particular age, and those happen to be very few and far apart. And there were also some people in there that lied about their age. So if you kind of um, make it into a group, you're kind of allowing the model to correct for these issues for you. So you would think a lot of people are of this notion, well, and it's more like the model driven instead of the model centric approach instead of the data driven approach, which is a data centric approach, which is, just throw anything in the model will take care of it. And that's a very naive way of looking at it.
mm.
Once you start kind of interpreting the models and their outcomes well enough, you realize there's things you can do that will help the model do its job better. because no, it can't, absolutely not fix every single data problem for you. You know, you have to fix the data to make the model better. um, the model won't automatically do that. And yeah, it is true that they're very sophisticated models like Cat Boost that will do a lot of things for you. They'll if you throw in like data with missing data to it, it'll kind of do some fixes for you. And if you throw categories that are too many, it will find ways of encoding them in such a way that they work out. But it might do these, since it does these things automatically. And the same goes for a lot of like auto ML techniques. Like
Mhm.
a lot of things can be done automatically for you, but it doesn't mean that the default things that were done for you are the best, are the most optimal. And since you're the owner of the data, or you're the specialist of the data in this circumstance, it is your duty to ensure that the data is valid enough to go down this process.
You've touched quite an important point that I was going to get onto next. And with your agent outcome analogy, that is cause and effect. And I was going to
Yeah,
ask you about that. How important is causal inference when it comes to interpretability?
100%. I mean, I like Packt has a great book on causal inference, um, by Alexander.
Well,
Yeah,
Alexander,
exactly.
and
Yeah,
he loved your book as well. He's
yeah,
graciously written a forward on yours.
yeah. And and the book is I didn't go down this rabbit hole too much. One of the
Mm.
chapters relates. It has a piece on causal inference, and I think with machine learning, even though we don't have the same tools that causal inference, I mean, at least traditional machine learning, the one this book deals with, because you could say, well, causal, there is causal machine learning, right? But I think we since we don't have the same tools, but we can
Mm.
definitely adopt the same thought process. And the thought process is, I'm going to interpret the data to figure out that what it's doing is sound from a cause and effect standpoint, you know, and it's never going to be the same as causal inference, because the model is not necessarily going to connect the dots in the same way. It just can't, because it doesn't have the same architecture.
Mm.
However, I think if we cover a lot of these bases, if we make sure that the data is sound, that there's quality, that the model's doing, that's connecting the dots more or less in the same direction, we're going to have outcomes that are doing what they're meant to be doing, that are that come from this process that is well thought of, and is grounded in our domain knowledge and our expectations to solve the problem the way it's meant to be solved. Because as I said earlier, like, you'd be surprised how many times the model might get things right, but exactly for the wrong reasons.
Mm.
And all it takes for the data conditions to change, for that to be, uh, you know, something that will yield negative outcomes for your company and your bottom line, because you know as soon as the data changed a little bit, that's all it took for the model to go sideways. Um, so I think cause and effect is definitely a good framework um, to adopt.
I can see chapter 11 of your latest edition is dedicated to that bias mitigation and causal inference methods.
Hmm.
And I was going to ask you a next question around that, which is quite a bit of a coincidence. It's like you're interpreting me and predicting what my next question would be about. But before I come to that, there is a question from someone on the LinkedIn chat. Tariq inquires, as well as the book, obviously, what tools would you recommend for beginners in this space? Thanks.
Mm. Well, uh, tools. I would say, well, I mean, there's the Python libraries that are in the book. Um, I mean, the book has a lot of Python libraries. Not all of them are something I would put them on equal par, but they definitely all are quite useful for their whatever they're specialized in. So SHAP is quite useful for explainability. Even though it has its flaws, I would still use Lime in many use cases. The same researchers of Lime came up with anchors, which I think are great. I definitely think that many times you want to think things in a counterfactual light, because that's one of the first steps to going down the path of causality. Because um, when we think about cause and effect, we're often also thinking about not just this happened because of this, but what would have happened had we not done this. In
Mm,
other words, what's the counterfactual reality? And if we see things that are counterintuitive, once we go look at them that way, that's when we realize there's something wrong with the model, for sure. And when we think about even tricking a model, it has a lot to do with counterfactuals too, because it's doing something it's not meant to be doing, despite it being something that we would see as obviously, um, like for instance, I give you an example. Like if we have a computer vision model that's meant to detect a human face, and then I put on a T-shirt with someone's face on it, right? And it detects a face there. That's unexpected.
mm,
It is technically correct, but it's unexpected. So that's a form of trickery. Like you think, well, how do we overcome that? So often you have to think of things in terms of their counterfactuals, because that's how you lead to, okay, well, this is I want a direct connection from here to here, from this cause to this effect, a person's face to a detection of the face, not a facsimile of a face to that. So we have to, there deep down, it's also a question of, okay, the tools you'll need have to do with the kind of problems you'll solve. But
mm,
I think it does pay off to look in as many tools as possible, because in other words, you won't know what tools you need till you kind of run the gamut, right? It's like, you need the toolbox, and then, or at least like the most basic toolbox, which covers all the different things that you would need before you can realize, okay, these are the ones I'm going to use the most.
mm,
And so the book is a great way to discover this toolbox. Um, but the beginner toolbox could be any one of those tools, depending on where you work and what your interests are, and all that. Um, so I'm not comfortable with saying beginners should only try these tools. I think beginners should try as many tools as they're capable of using, and then uh, you know then from there they should discover which ones they find the most useful.
mm. I think that's important not to limit a beginner to a certain tool, especially at the beginning of their journey. I'm aware of the time. We've just got 5 minutes left, and we'll do a final raffle, and then we'll see if we have more time left. So let's do our final raffle first. Let's see how many people have entered. So Tariq was our first winner, and we've got more people who've entered the raffle now. Can you see my screen, Suraj?
Hmm.
Perfect.
Yeah.
So let's draw it again and let's see who the new winner is. Congratulations, Tejas. You're watching it on YouTube. I'm very easy to find on LinkedIn. So if you can just drop me a line on LinkedIn, that would be really helpful. Just share your email address, please. So yeah, I can ensure that the ebook is passed on to you. Congratulations once again, Tejas. I hope you are watching us still. Excuse me. Oh, sorry. So, Sir, before we call it a wrap, there is one quick question from Gulrez again on YouTube. Does interpretability include bias in the model results since there is a human element involved in certain cases? Isn't that called human in the loop?
Yeah, I don't think interpretability introduces bias. I
Mm,
think bias is introduced by the data itself. It's introduced by the modeling process. Um, it could be introduced by the prediction, because if you predict something that's biased, it might lead to more biased data, you know. So there could be like a feedback loop, a negative loop, a downward spiral, if you will,
mm,
um, involved in that. Um, I don't think interpreting it could. I think it could only lead to better results. I mean, if you're being like meticulous about it, if you're trying to not produce harm, I think it can only improve things. Yeah, there is the models, your model choices, I mean, can introduce bias. Every choice you make as a as a machine learning practitioner can introduce bias.
mm.
What hyperparameters you use, all that can add bias to the model. But that's something we have to watch out for. I mean, for sure. And it's not, as I said earlier, it's not just a question of the standard metrics, not even just looking at the overfitting, because just examining the outcomes, examining the feature importance and things like that can lead to improving, to reducing the bias of the model.
Perfect. Thanks a lot, Gulrez, for your query and Serge. So, Serge, do you have any closing thoughts that you would like to share with everyone watching before we call it a wrap?
Not really. I think um, I hope everybody's as excited about this book as I am, and join me on this journey. I think the book is it is a space that is very much important. Like if you came from software development like myself, you know that debugging is important. It if and quality assurance is important. All these things relate to what the book is talking about. Interpretation is also something that is, if you came from a science background, interpretation is key in science
Mm,
and in statistics and all these fields. There's a reason we do it. We want to trust our results. And if you come from data, that's key. And so you'll also know that that's something you should watch out for. So, and from a business perspective, the same. If you come from a business background, you know, you want to be able to trust your products. So I think from whatever angle, this book is definitely something worth looking into. Um, and 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 I'm very proud of it, and I hope you like it.
perfect. Thanks a lot, Serge. Thank you, everyone, for your time. Hope to see you soon with another one of our Expert Insight sessions.
Sure.
Thank you so much.
Thank you.